Hello, welcome again. We are solving some questions of thermal engineering. The topic is IC engine plus gas turbine plus compressor. Question number 101 from Gate 2014 ME-01 is: in an air standard Otto cycle, air is supplied at 0.1 MPa and 308 Kelvin. The ratio of specific heat gamma and specific gas constant R of air are 1.4 and 288.8 joule per kilogram per degree Kelvin respectively. If the compression ratio is 8 and maximum temperature in the cycle is 2660 Kelvin, the heat in kilojoule per kilogram supplied to the engine is dash. So here the air supply temperature is 308 Kelvin, or T1 is your 308 Kelvin, and compression ratio is given as 8. So it means V1 by V2 is your 8. Okay, so V1 is your total volume and V2 is your clearance volume. So V1 by V2 is your 8, or R is your 8. Okay, the maximum temperature of the cycle is T3, that is 2660 Kelvin. Okay, and specific heat ratio gamma is your 1.4. R is 288.8 joule per kilogram per degree Kelvin. So these data are given. Now, as in Otto cycle, 1-2 is isentropic process, 2-3 is constant volume heat addition, 3-4 is isentropic expansion, and 4-1 is constant volume heat rejection. So 1-2 being isentropic process. So for isentropic process we have V1 by V2, V1 by V2 is equal to T2 by T1, is for 1 by gamma minus 1, and V1 by V2 is your compression ratio, that is R. So 8 is equal to T2 by T1, is for 1 by 0.4, or we can say T2 by T1 is 8 is for 0.4, or T2 by T1 is 2.2973, and T2 is your and T1 is your 308. So T2 is your 308 into 2.297, or 707.59 Kelvin. Okay, and now R is your 288.8, and R is equal to Cp by Cv. Okay, so and Cp by Cv ratio is 1.4. So from this we have Cp is equal to 1.4 Cv. So 1.4 Cv minus Cv is your 288.8, and 0.4 Cv is your 288.8, and Cv will be your 288.8 divided by 0.4, that is 722 joule per kilogram per degree Kelvin. Okay, so now we have found out Cv, we have found out temperature T2. Now we have to find out that heat supplied to the engine. So heat supplied is during process 2-3, which is constant volume process. For finding out heat, we need T3, we need T2, and we need Cv. Okay, so Cv we have calculated, that is 722, and T2 we have calculated, that is 707.598. Okay, and your heat supplied is Cv, T3 minus T2, and T3 is given. So putting this value, T3 as 2660 and T2 as 707.598 and Cv as 722, we can calculate heat supplied. So that is 1409.634 kilojoule per kilogram. Okay, so answer is 1409.634 kilojoule per kilogram.